Welcome back to our Algebra 1 series. Today we're up to section 3.5. We'll be adding and subtracting polynomials. Here's an example. 3x cubed minus 2x minus 4 is the first polynomial, and we are going to add 4x cubed minus 3x squared plus 2 as the second polynomial. This can be rewritten without the parentheses. The next step we would do is collect like terms. The terms in red are like, and the two terms on green are also alike. This simplifies to 7x to the third minus 3x squared minus 2x minus 2. In this case, it's written in descending order for x. Next, let's subtract these two polynomials. Remember, when you see a negative sign on the outside of a parentheses, it's applied to each term on the inside of parentheses. So the sign flips for each term. The 4x cubed becomes minus 4x cubed. The negative 3x squared becomes a positive 3x squared, and the plus 2 becomes minus 2. In each of these terms, the sign has flipped. The same process is carried out, however. We collect like terms, and we simplify. We end up with negative x cubed plus 3x squared minus 2x minus 6. Let's jump over to the whiteboard for some examples. Alrighty, let's write out a polynomial. 3x squared plus 2x minus 2 plus negative 2x squared plus 5x plus 5. Okay, so I'm going to take away the parentheses, but to do that we need to make sure we rewrite this properly. So this one will end up being minus 2x squared plus 5x plus 5, and everything else is the same over here. 2x minus 2. Okay, let's look for some like terms. We've got x squared. Okay, so those can be combined. We've got x, and then numbers. So we have to do this 3 times. Let's start with x squared. 3x squared minus 2x squared. That leaves us with just 1x squared. 2x and 5x is 7x. Minus 2 plus 5 is plus 3. What I'd like to do is the same problem, however, we're going to subtract. Big fat minus sign. So I'm going to rewrite these two polynomials, keeping in mind this minus sign is here. So let's just start from the left side. 3x squared plus 2x minus 2. Nothing has changed. So now we're subtracting a negative 2x squared. So we're really adding 2x squared. We're subtracting a 5x, subtracting 5x. We are subtracting 5, subtracting 5. So negative, positive, positive has flipped to positive, negative, negative. Okay, so now we can combine like terms again. 3x squared and 2x squared is 5x squared. 2x minus 5x, negative 3x, minus 2 minus 5 is minus 7. So you can see we got very different answers just by flipping the sign. Next, let's talk about the column technique. It's a different method of solving the same kinds of problems. So let's say we have two polynomials that we would like to add. We can rewrite these polynomials by aligning the like terms. All I've done is stretch them out so that the like terms are on top of each other, kind of like stack 'em style. Then you would just add downward for each like term. This results in 9m to the 5th plus 5m to the 4th minus 2m cubed minus m squared plus 9. This simplifies the problem when you have a lot of terms and all you need to worry about are combining the like terms. Let's do a couple examples over on the whiteboard. Okay, so let's add these two polynomials, but let's do them in stack 'em column style. I'm going to start with the first one right about here. 3x cubed y plus 6x squared y cubed minus 4x. I'm going to put plus 3 over here. So for the second one, I'm going to start writing it over here. 2x fourth y minus 4x cubed y plus 6x minus y. Ooh, that was a crazy y. You're a lot of control there, buddy. Okay. Minus y. So what I've done is I've aligned the like terms. So we can just make a huge problem out of this. And huge, I mean size, not in complexity. So there are no like terms, so this just comes down to x to the fourth y minus, okay, so we have 3x cubed y minus 4x cubed y. So this gives us with minus 1x cubed y. This comes down. There are no like terms to combine, so it's just 6x squared y cubed squared. All right, we have like terms here. Negative 4 plus 6 ends up with plus 2. We didn't have like terms here, so it just falls down by itself. And again, don't have like terms here. Oh boy, so that's the answer. So you can take two complicated polynomials and use the stacking method to align the like terms. Finally today, I'd like to cover what I call shape problems. For example, here's a triangle. The length of each side is being expressed as a polynomial. What we're trying to do is express the perimeter as a simplified polynomial. Remember, the perimeter is just the sum of the lengths of all sides. So what we really need to do is just add these three polynomials together. Here, it makes sense to use a stack-em style, as you can take the three polynomials and align the like terms. 3x minus 1 plus 3x minus 1 plus 3x squared minus x minus 12. And as you can see, we've aligned the like terms, and we combine the like terms. So the perimeter of this triangle is 3x squared plus 5x minus 14. All right, let's go do one over on the whiteboard. Let's just draw a big rectangle here. We're going to pretend these are straight lines, right? And I'm going to draw a smaller rectangle on the inside. Now the length of this side we'll call 2x. And the length of this side we'll call x. And we'll call the length of this rectangle 2. And the width of this rectangle 1. And so the question is, what is the area of this chunk here? Remember, area is length times width. But we just want the area of this outer part. So how can we figure this out? So let's figure out the area of the biggest. This whole area is going to be the length times the width. So we'll have 2x squared. That is the area of this entire large rectangle. But we need to subtract out this part. We want the big area minus this inside area. So the inside area is 1 times 2, which is 2. So the area of this hashed out area around is 2x squared minus 2. That's it for new material today. If you'd like to see some more examples, stick around. Okay, let's subtract a couple polynomials here. 5x squared plus 6 minus 3x squared minus 8. Okay, so remember this minus sign needs to be applied. It's almost like distribution, right? So let's just rewrite it as 5x squared plus 6 minus 3x squared. We got minus and minus. This will be plus 8. The sign flips from minus to plus because the minus is on the outside. So now let's look. We have like terms, so x squared, that's a like term. So 5x squared minus 3x squared is 2x squared. We've got 6 and 8 gives us plus 14. Let's do one more subtraction problem. I think we have enough room here. 7a cubed minus 2a squared plus 6 minus 7a squared plus 2a minus 4. All right, we're going to rewrite it again. This part stays the same. Plus 6. Remember, this minus is going to flip the sign of everything on the inside. So we have minus 7a squared minus 2a plus 4. This minus flips because of the minus out here. So let's look at some like terms. We got a 7a cubed, but no any other 7a cubes. So let's just write that one by himself. 7a cubed. All right, a squared minus 2a squared minus 7a squared. So that's minus 9a squared. We've got this minus 2a. That's the only a by itself. So we just rewrite it. Minus 2a. We have plus 6 plus 4. That's plus 10. So we've flipped the sign where we needed to, and we've combined like terms. This is also written in descending order to the variable a. Okay, let's do this subtraction problem, but we'll do them in the stack 'em style, column method. We've got 6y cubed minus nothing y squared minus, we put a plus there if we wanted to, minus 4y minus 7. So we're going to subtract and put it way over here. A minus 3y to the 4th minus 2y cubed plus y minus 4. So there is no y squared item here. I didn't need to leave this gap, but to me it makes sense. 4, 3, 2, 1, 0. That way we know there's no like terms of y squared. So now, there's something minus a minus 3y squared. So remember, this minus sign out here is important. So minus a negative. This ends up being a positive 3y to the 4th. 6 minus a negative. So we're actually adding 2 plus 8y cubed. A whole bunch of nothing. Negative 4y minus another y minus 5y. Negative 7 minus a negative 4. So we're really adding 4. So this is negative 3. And we could crunch this all together, but this is the final answer once we've used the stack 'em method. Okay, we got us a triangle here. Something like that. That's almost a triangle. And the length of each side, I'm going to write down as a polynomial. 15x minus 3, 10x squared minus 2x plus 7. So the question is, what is the perimeter? So we need to add these together. So let's combine like terms visually. How many x squareds do we have? We have 10x squared and 3x squared. So that would be 13x squared. What about x's? We have a negative 2x and a positive 15x. So we're going to have 13x. And let's just look at the numbers. 7 plus 4 minus 3. 7 plus 4 is 11, minus 3 is 8. Plus 8. So the perimeter of this triangle, as it's expressed as a polynomial, is 13x squared plus 13x plus 8. And that's it for today. We'll see you next time.